We're going to start with number 13 from yesterday. And if you watched yesterday's videos, I used last year because I had so many technology issues yesterday that it just didn't work. So you may have seen this on yesterday's notes, but that's fine. So number 13, we have, and I'm going to write this out a little bit bigger, 5 plus 3i over 1 minus 2i. When you have 1 minus 2i in the denominator, the problem is that I is the square root of negative 1. So we have a square root in the denominator, and that's bad. So we're going to multiply both the numerator and the denominator by the complex conjugate. The complex conjugate is the exact same thing as the denominator, but change the symbol. So this says 1 minus 2i. We're going to multiply by 1 plus 2i. You use the same two terms, 1 and 2i, you just switch the symbol. And you multiply both the numerator and the denominator by that. So in our numerator, we're going to have to double distribute. 5 times 1 is 5. 5 times 2i is 10i. 3i times 1 is 3i. And 3i times 2i is 6i squared. On the bottom, we also double distribute. 1 plus 2i minus 2i minus 4i squared. Okay, in the numerator, I've got the number 5. I've got these like terms, 10i and 3i. They combine to give me 13i. And then let's talk about this 6i squared. 6i squared is 6 times negative 1, because remember, I squared equals negative 1. 6 times negative 1 is negative 6. So instead of plus 6i squared, we have negative 6. On the bottom, we have 1. Our two like terms cancel each other out. Negative 4i squared is negative 4 times negative 1, which is positive 4. Finish combining your like terms. On the top, 5 and negative 6 is negative 1. So we have negative 1 plus 13i. On the bottom, 4 plus 1 is 5. You did this correctly if you have no i's in the denominator. By multiplying by the complex conjugate, you are getting rid of the i's in the denominator. In your notes where it says day 2, please cross out the square root of I because that is very incorrect. We need to remember that the square root of negative 1 is the imaginary number I. Okay, I'm going to write this a little bit more spaced out because I like my space. We have x squared equals negative 36. How do we undo the square? Square root. And when we put a square root into an equation, we have to put a plus minus in front of it. If the square root is already there, you can assume it's a positive square root. If you have to put the square root in, you have to consider the potential for both a positive or a negative square root. So on the left side, the square root of x squared is simply x. On the right side, we need to take the square root of negative 36 and simplify it. It would break into the square root of negative 1 times the square root of 36. The square root of negative 1 is I, and the square root of 36, 6. So x equals, don't forget about your plus minus, plus minus 6i. What would you do first in number 2? Subtract 26. When you solve equations, you're doing PEMDAS backwards, which is actually SADMEP. PEMDAS backwards is SADMEP. So when you're solving equations, you want to use the order of operations backwards because solving equations is basically undoing math. So subtract or add first. So we have 2x squared equals negative 36. Then we would divide or multiply. So how do we get rid of that 2? Divided by 2. X squared equals negative 18. Then we deal with any exponents. How do we undo the square? Square root. Don't forget your plus minus. To keep my work organized, I always do my simplifying off to the side. It just makes more sense in my brain. If you want to keep going in one string straight down, go for it, but I like to do my simplifying off to the side. I know there's a square root of negative 1. That's what makes it a negative 18. Think about positive 18. What can you split positive 18 into? Square root of 9, square root of 2. The square root of negative 1 is I. The square root of 9 is 3. You've got the plus minus symbol, I, 3, square root of 2. How do we get all of that into a cohesive answer? X equals plus minus the number 3, the I, and then whatever's left under the radical, square root of 2. Once again, I am going to write SADMEP on the page, PEMDAS backwards, because I want you to see how this equation really truly follows the order of operation backwards. According to the backwards order of operation, when you're solving, you're undoing math, so do order of operations backwards. We need to subtract or add first. So we need to get rid of this minus 4 by adding 4 on both sides. Can we distribute? Is that clear enough? Don't distribute. Because there's a square on the parentheses, you cannot distribute. That would be multiplying. You can't multiply into something that has an exponent on it. You would have to do the exponent first. But we can divide both sides by negative 4. And I'm going to leave this as the fraction negative 9/4. Next, we would deal with our exponent. How do we undo the exponent? With a square root. Don't forget about your plus minus. Okay, over to the side, we've got the square root of negative 9 over the square root of 4. How can we split up the square root of negative 9? Negative 1 and positive 9. The square root of negative 1 is I. The square root of 9 is 3. So the top part of this fraction is going to be 3i. What's the bottom part of this fraction going to be? 2. The square root of 4 is 2. Okay, now I know the parentheses aren't still written here, but our last step is to deal with our parentheses. We used to have parentheses around the x minus 5. Now that those parentheses are gone, we can do the stuff that's inside the parentheses. How do we get rid of the minus 5 from inside the parentheses? Add 5 to both sides. Our final answer is 5 plus or minus 3I over 2. Your assignment is page 109 out of the textbook, yes, the textbook, numbers 49 through 57.